We're going to talk about 5G. 5G is a major initiative in the service provider realm now because it allows them to build new services, capture a higher revenue stream than what they were able to do with 4G. 4G really had a consumer focus, and 4G was really about driving smartphones and adoption in consumers to a new way of using cellular technology. Now, everyone has smartphones. The smartphone market is reaching a saturation point. So 5G has to be much more than giving people simply a better user experience with smartphones. So what the industry is looking for is delivering not only consumer services, but also business services, also fixed services. So this is going to be a major platform for innovation. So let's talk about what are the underpinnings, what are the key things that are happening in 5G. First of all, there is going to be a significantly high bandwidth. People are talking about 10 to 100 times the bandwidth that you can get on 4G. Extremely low latency, and this is going to enable services like autonomous vehicles, sub 15 millisecond latency, and better spectral efficiency. What spectral efficiency means is how many devices that you can connect to the network in a fixed spectrum. As we all know, spectrum is a precious resource. So in 5G, what the technology has done is you can pack now billions and billions of devices into relatively constrained spectrum, which was simply not possible with 4G. So even though 4G had IoT services and devices, but it couldn't scale cost effectively like you can do with 5G. So high bandwidth, low latency, better spectral efficiency. Those are the key things that are going to make 5G enable and unlock a lot of value for service providers. So fixed and mobile services. Let's talk about fixed first, because this is unusual. In the traditional world, fixed services were offered either on cable, DSL, or on fiber. They were all wired technology. Delivering fixed wireless was not possible because the bandwidth and the technology was not there. But with 5G, there are unlocking higher frequencies, which are called millimeter wave frequencies. In these frequencies, you can deliver 4K video at extremely high quality. So this enables now service providers to go after the home market, which was essentially dominated by cable providers now. So fixed broadband, in addition to mobile broadband on a common infrastructure is what the communication service providers are planning to do with the 5G technology. So it opens up a much larger market segment, even for consumers. So that's a key point to note. So let's talk about what are some of the key technology underpinnings under 5G. Clearly, a much higher frequency spectrum. Now we are going to not only mid-band, which is around 3.8 gigahertz, but also 38 gigahertz, which is the millimeter wave band, which is where you can unlock high bandwidth. Another aspect of 5G is what we call a distributed cloud framework. So this is the first time that a native cloud-based architecture is being adopted in a service provider network. The centrally controlled architecture of 4G, which was good when all the services were going to the internet, is no longer good when you're talking about services like connected cars, AR, VR, which is more peer-to-peer type services. So in this architecture, you have to create a distributed cloud framework. And not only that, you have to move some of the functions to the edge because you want to provide low latency and also you want to provide higher bandwidth. So we call this a distributed edge and core cloud. So the centrally controlled cloud now gets distributed into an edge and core. The third thing that is happening is the separation of user and control plane. Now, what does this really mean? Typically, when we have a service like voice, which has a control plane, which is how you set up a call, and then user plane, which transmits data, they both essentially traverse the same path. Now, that is good enough for a service like voice. But when you're talking about services like connected cars, AR, VR, they need to have much lower latency. The user plane needs to move closer to the edge, which means it needs to be separated from the control plane. The control plane you want to centralize because you want to be able to manage and control services from a central point in your network. So this separation of control and user plane is a key aspect of 5G. The last important point I want to make is a feature called network slicing. Now, why this is necessary is traditionally wireless networks have only one way to provide a quality of service to all the customers who are using that. With network slicing, a service provider can create virtual slices on the same physical infrastructure and provide a different level of what we call SLA, or a service level agreement. This could be based on latency, this could be based on throughput, this could be based on a combination of those, and could be based on availability. So each slice will have its own service level agreement, and each industry vertical could then use that slice that is appropriate for its service. So for instance, connected cars might use one slice, e-health services might use another one, and energy and transportation could use a third slice, which have different characteristics. So that is extremely important because it opens up the spectrum of what kind of customers and services they can go after. Now, with all the changes, what does it all mean from an operational point of view? So there are a lot of changes in the network, but operating such a network, giving customers the right user experience, the right application experience is going to be key to the success of 5G. So when we talk about millimeter wave, one challenge with millimeter wave is the range is very short, it is very susceptible to attenuation and deterioration. So the quality of service has to be very carefully managed. The second aspect is when you create an edge core cloud, there is a mesh of traffic flow that happens. Not everything is going to a central point in the network. There is an edge to edge traffic, there is an edge to core traffic, and all of these flows have to be monitored, correlated to put together an end-to-end picture. So that is going to be extremely critical. When you talk about slicing and SLA, so you need to be able to monitor each slice for the right level of performance metrics and be able to make sure that those performance guarantees that you're making with the customer are actually enforced. The third point is this new architecture opens up a whole bunch of new attack surfaces in your network. So the security challenges increase. The edge is a new deployment model and it has its own challenges. The services themselves, like connected cars, they have their own security challenges. So all of these have to be managed in a way that hasn't been done before. So in summary, Netscout can help you in these three key areas: ensuring application performance, ensuring pulse slice SLA enforcement, and security challenges due to new attack surface vectors.